Hi, I'm Martin. I'm doing this video to explain a library I wrote. It's called Prime SVG. It's not publicly available because I haven't had the time to make it open source. I want to do it, but just haven't been possible. I've been using it the last years in my projects. I work mainly with Vue.js and as a full stack developer. And I wrote it because I needed an easier tool to make customized charts. There's a lot of projects that requires for me to do that. You will interact the first time with this library probably when you visit my personal website. There is this cool map that is built with that. It's a vector map and has pretty good performance for what it does actually. If you want to spin it really fast, it's not the right tool. You will use a canvas graphic, but yeah, I will show how it works and why I built it, and it's how it really impacts the workflow of developing customized graphics. So let's start with the beginning. There are two things I think they were really important for me when I started building this library. The first one was the inverted plane that is used for vectors. I find it a bit unnatural because when you learn geometry when you are a kid, normally you learn things from the bottom left to the top right only in a 2D world, because if we are talking 3D, it's a different story. But you see this, for example, in this chart that is built with the 3 histogram. Okay, let's first see the amount of code that is required just to build some rectangles stacked and some scales that are just a basic text. So there's a lot of code involved to build a pretty simple chart. That's one thing, and the other thing you can see in this chart is that here, when you see the methods applied to the DOM, you can see that the coordinates and the dimension of the things are normally inverted because of the inverted Cartesian plane. So that's the first thing. And the second thing is the amount of code involved of doing this. Also, when you want to maintain this and do some modifications or do it more interactive, you have to deal with a lot of like functional code that is not so intuitive when you are used to work with more, I don't know, contemporary tools for working with the front end. So yeah, this is good. You can build a chart, but maintain it and apply complex interactions requires a lot of code. So if you want to add tooltips to this or animate this, you'll have to do a lot of modification to this code to make it work. And especially if you want to make it reactive or want to load data dynamically, most of the time what people do when they work with this approach is that they just rebuild all the chart all over again, because this is just creating a container and adding some elements to the interface and then just changing their style, but it doesn't allow for you to apply changes to the elements. So each element you have to like map it on the instance when you are initializing it. So it is not so good if you want to do more complex charts. So, and we see the same story with these things. So D3, what is really good doing is allowing you to do complex shapes like these ones that you just initialize, in this case with this arc method. And so I thought, why not just to bring together Vue, it's a reactive system with its properties, and remove all these functions, all these methods, and just make it available as properties, because most of these things are just properties being called through a method. So you see here, this is a scale that it has a range. So it's a radial scale that has a domain, a range, but you can represent this with an object. It doesn't need to be a method. And also these things, width, height, viewbox, they are all like properties. Actually, they are properties from the native properties from HTML. So now I will show you how what is my approach for this problem and how I build my library. Now I will show you my approach to the problem. So let's analyze this histogram. It's just a group of rectangles. Actually, they are wrapped in a group element here. They have in a group to move them around. Normally, when you see the three graphics colors used to that, they grab them in a group, because group you can just position it wherever you want, and they just start then adding the scales and stuff. So yeah, my system works a bit differently, actually a lot differently, and let's see the code, then I will show more examples about every component that composes the library. So the first element is the rectangle. It's one of the core elements of the HTML vector native elements. And here you can see how it works. It's really simple. So I here just create an array with and fill it with zeros. Then when I mount the component, I just add some random numbers from 0 to 1 with only 2 decimals. And here I just instantiate the library. The first element is prime SVG. That is the container. Is like an alias for the SVG container of HTML, but it has a lot of cool properties that it can do a lot of stuff. It can be always responsive, so it will always contain the graphics wherever the elements are positioned in the canvas you're working, if you want to say in that sense. You can also set the refresh rate of how fast you want the changes to be considered for the elements. So I can just say 2 milliseconds of how it interacts with the updates, because when you want to do it in a high performance way, you have to do a lot of debouncing. So you have like a 1000 element chart. Each element, if you are moving them around, will send an update. You don't want to make reactive the chart for the 1000 changes that could happen every second. So you have to use debouncing, and also it supports refresh rate. And for example, the scales that you will see in the code here in various parts. For example, here is the scale linear. It's just a linear scale to represent like a range. I just have this file that is called scalar. I just instantiate a bunch of scales. So the quantize, linear, quantize, threshold, and among others. I also integrated here a library that extends the D3 scale. That I actually extend the scale with a few other scales that are pretty handy. And here is the component. It's pretty simple. It's the rectangle. Here's just a loop, and it has a customized coordinate system. It also works with the base coordinate system. So if I set 10, it will work. But it has this coordinate system that I had to create to kind of convert the previous one to always have an equivalent usage of the scale. Also here, for example, in the bottom, the circle has the same notation. Normally in the circle you use center X to move the position of the circle, but I just make an equivalence for all the elements to use the same notation, text, anything, make it easier, because some elements in the vector native elements had different notations to work with the the position of them. And here, for example, you just call the normal properties. Here is an interesting one. It's called watch all. That is a property that allows to watch any change on any of these properties to make them reactive to change, to make to send updates to this contain property. So you can also select them granularly. So you can also select only the position, only the width or the height, but this is like a practical way to just watch any change and make the chart always be updated and contained. And as you can see, I'm just here calling the rectangles in a loop, just moving them. I could also use like a band scale, but here I'm using just a linear to make it simpler. And also, as you can see, the prime SVG, prime G, that is the group, allows you to make an object with any amount of scale. So here I can add another scale for the width, for the height, for anything. I can also bind the same scale helper here in the prime SVG, and also in another renderless element that I have that is called a container. I just have anything, and you can use them in non-vector shapes, and when you need to have something that it doesn't interfere with the interface. So another interesting thing that you will see here is, for example, how it handles the text. For example, I added a text here. I set the dominant baseline to be in a hanging state, so it grows to the bottom, as you can see here. And to move it a bit lower, as you can see here, to be a bit below this blue line, I just added this coordinate as a -10 for it to be here in the bottom. So if we will be working with normal vectors, we will put it here at 10, which is weird. So and another thing I did to show how it works is any element you can change its orientation pretty easily with just this property: center, right, left, or right. As everything is computed in Vue, you can just have like a rectangle and then change its orientation pretty easily with just one single property, which is pretty handy. And we are not considering also that you can bind anything here, tooltips, anything you will like. The second example is this circle that is here, like orbiting and intersects in this point here, and just requires this. Normally in a vector shape you would probably require a similar amount of code, because these are just native elements. They are not too complex to be built. But what I wanted to show here is how the chart works in a reactive way. Here I also set like a circle to just set the working space. Normally you see here that in the graphics, normally what they do when they work with these three is they set the view box of the container, of the SVG container. But the approach here is a bit different. If you want to contain something in like in a container, you just make a shape that is the size of the container. You just make it transparent, and the graphic will automatically contain it. So you have a working space, because when you are doing a system that is contained and is reactive, it will handle the growing. I will show it right now. but it's not so practical. For example, I will show it here because it requires more effort for the interface. For example, in this circle is reactive. So as you can see, when I make it grow, make it smaller, it just reacts how it should be doing. So. But this is the way to work with this library. It's pretty easy to work almost anything, and it is also really nice to be able to just have the ability to make them completely reactive. You can do whatever you want with them, and you don't have to use any sort of function to use them. So let's start watching what is composed this library with. So first, there's the native elements of SVG: circle, rectangle, ellipse, text, a polyline is one, the line, mask, click path, the group element. And there's a lot of also aliases that are generated with the three. That is, for example, the arc, that is just a path that, or more than an alias, I would say it's a generator. So the three has a lot of generating functions for complex shapes, and I will show you how they work. This is an interesting one, the SVG container, because you saw how it contains elements, but also it allows to bind properties as hover. For example, I just move around elements and just allows me to interact with different scopes of the graphic. I can also watch clicks, selections, and all other stuff. So yeah, it's pretty easy to make interactive charts when you want to, for example, select elements in the interface and make them, highlight them. It's easy to do that. Here in the circle, if you see the code, I made it intentionally set the watcher to watch all. So whenever I change the radius, for example, it will contain it. So as you can see, it will always contain it. And this effect change by the speed you set to the refresh rate. So this is why you see that sometimes that it gets outside and then it is contained. You can make it speeder, but you have to just test the performance of how it handles it. And for example, the rectangle one, I made it intentionally non-reactive, so it's not watching anything. By default, the contain property will take any element you throw at the interface and will show it, and will contain it in the first rendering. So that's why you see it this way. And if I change something as it's not watching anything, it will not change the dimensions or will not center it. And then there's also the other native elements as the ellipse, text with all their properties. Here I have my documentation for how any of these variants is used. This also I think I built this way of stacking this, especially when I have a lot of examples. It's pretty common to be seen in websites actually. And this is the curve element. It has also a lot of variants. Then it just generates a curve with a specific kind of projection you want to use for the way you want to render it. This documentation is not made for this, so this on Nuxt. This is not done for Nuxt, the main code. So sorry about this thing that is overflow. But example, here you can see how it handles different curves. The curve when you work it in this, actually this I think this was one of the elements that wasn't reactive. like when like by default, so you need to treat them really specifically to ensure they are always reactive and they behave in the way you want. This is actually set at a specific speed. You can make it really fast, like behave like a snake actually, but any of those decisions have a cost in terms of performance for the interface. Then you have the arc. You can do a bunch of things with this, and and then you have some pretty interesting ones. So there's polygon. Yeah, the polygon also generates automatically the sides of the polygon. And I will show you now some really customized ones. Well, there are really good ones. For example, the link one. It's pretty simple to implement. It's just this. You have an origin and a destination, and it just creates this link in any of these styles. I made a bunch of styles to that could help you handle the tension of the curves, the way it is connected. So it's pretty handy to make, for example, flow charts or anything like that. Also the scales. Here's the docs for the scales. There are a lot of examples of how they used. This documentation for myself to remember what's the best use case to use these scales, because they are just too many. And wait, I know what I click here. And I also develop a lot of like helper components. So yeah, there is a map. You already see how it works, and there are some renderless components as this one. This container just does exactly the same as the group. What this group does, but it just does it renderless, so you can bind it to any like HTML non-vector element, and it's pretty handy if you want to reuse scales or wrap some big div where you have a bunch of graphics with just a container, and you will use the same scale for example the something that is outside the vector. This is pretty handy. So this is handled the same way. So it's here. Prime container here. As you can see, it's just like a renderless component that allows you to interact with these scales. And then you have some other helper renderless component as the centroid. This works a bit differently. You have to set the dimensions. Normally you have dimensions when you are working with scales in some way, and you set the orientation of how it works. So it generates the different centers of what is contained. So that is what it does basically. So it in an automatic way just checks what is inside itself and gets the right dimensions of where the things are located. I actually developed this because I had to make a bunch of software to make some interfaces that use the OKR indicators. So you need to connect different nodes and do the things that are done by, for example, libraries as ViewFlow. The use case was a bit more customized, so yeah, I need this. So I added this. This is one of the last things I added to this library actually. And there's also the auto points. I need to fix them because it's working in the inverted way, but basically takes the shape, path actually, and it fills it with points. You can set the separation of them, set the regular if you want. This is really handy if you want to. I haven't had to use it actually. I just did it because I wanted to cover some of the use cases when you do, for example, there's some kind of maps that you use this like XB maps. You have you have a path, for example this, and you want to fill. So you need to get the limits of the path and do some function to fill it actually. So that's why I built it. I haven't used it, so but it was a fun challenge to do. And yeah, that is most of the things that are composed with this library. There's a lot of utility functions to do transformations and other stuff, and it's pretty handy. It allows to build almost anything in no time. I would say. So there's no documentation here. Well, sometimes I'm not consistent with the documentation because it's just like this is not like a critical thing I need to remember. I just put bottom in a component and it's just there. So, but this is just like an internal tool I use for building my custom charts. So I want to end this video having some conclusions about the work done in this library. I think it's a great library. I actually use it in most of my projects, and I think the best thing is that it's really expressive. You want to like represent the chart, and it's pretty natural. You don't have to overthink the orientation of things, the dimensions. You can just trust the system will handle all the things that you are bringing the interface. You don't even have to think about containing stuff. You know they will render whatever you just put it, and that is pretty nice. Just having that certainty. I think you will be really benefit by having some a bit more complex charts to have, for example, 3D properties. It would be nice, or to be able to add canvas based graphics. It will also be benefit a lot to make a lot more complex charts. For example, this chart that is on the screen, that is a map. You are kind of limited by the vector technology of how it is rendering the and as a resource how it's handled by the interface. But I think that right now is a good library, and also it allows to do something really interesting, that when you have things organized in libraries as Vue.js, you can represent also graphics with objects. So it could allow to represent like more dynamic things. I think today with generative AI, it is pretty possible and easy to just make a model that, for example, could just represent in an object like a drawing, and this can handle it without all the hassle that is required to handle normally a vector, especially when we are talking about paths or we are talking about the orientation of things. So I think this approach has many benefits in the normal workflow that is required to like customize charts, and especially for that, because as I said in the beginning, if you're just doing a generic chart, it's better to use like another library. This is like a good library only if you need really specialized and customized charts for example infographics, or some panel that is just not supported by other libraries that require too much of a like effort to make modification that adjust the use case you want to do. And yeah, actually that is why I call it like prime SVG. The beginning I was thinking about something like a primal, like something really primitive that you can just interact with primitive shapes easily. That was the idea. So yeah, This is my project. I hope you like it, and thank you for your time.